Hey everyone, welcome. Today, we're going to jump into something super interesting and, really important for your exams, tangents to a circle. It might sound a bit tricky at first, but trust me, once you get the hang of it, it's actually pretty cool. Let's master this thing together. What do you say?
All right, here's our game plan. We'll kick things off with how a line and a circle can even meet. Then we'll get into two super important rules, and to wrap it all up, we'll tackle an actual exam problem together, step by step. Simple, right? Okay, let's get right into it. So picture this. You've got a flat piece of paper, a plane, and you draw a circle and a line. What can happen? Well, there are really only three possibilities.
So look here. Case 1, the line just, passes by without touching the circle at all. We call that a non-intersecting line. Easy enough. Case 2, the line slices right through the circle, hitting it at two different spots. That guy's called a secant. But the third one, that's our star for today. It's the line that just barely kisses the circle, just grazes it at one single point. And that special line is called a tangent.
So let's make this crystal clear. A tangent touches. Think of it like a quick high five with the circle, just one point of contact. A secant, on the other hand, cuts. It goes straight through. This difference, touching versus cutting, is absolutely fundamental. Got it?
And that one special point, the exact spot where the tangent and circle meet, yep, that has a name, of course. We call it the point of contact. It's their one and only meeting place.
All right, now that we know what a tangent is, let's get to the good stuff. I'm talking about its biggest secret, a rule, a theorem really, that you are going to use all the time. Seriously. Okay, here it is. Theorem 10.1. Now don't let the word theorem scare you. All this is saying is something really simple but super powerful. The tangent at any point on a circle is perpendicular to the radius at that point. In other words, they make a perfect 90-degree angle. Every single time.
Take a look at this diagram. See the line from the center O to the point P? That's our radius. And the other line is our tangent. Now look closely at where they meet. See that little square symbol? That's the universal sign for a 90-degree angle, a right angle. Remember this visual, because this little right angle, it's the secret key that unlocks a ton of problems.
So that leads to a pretty logical question, right? If you just pick a random point, how many tangents can you draw from it to a circle? Can you always draw one? More? Let's figure it out.
This table breaks it down perfectly. So what if your point is inside the circle? Well, try drawing a line. Any line you draw is going to cut through twice, so 0 tangents. What if the point is on the circle? Then you can draw exactly one tangent right through that point. And finally, the interesting one, if your point is outside the circle, you can actually draw two tangents from it. So the answers are 0, 1, or 2.
Okay, so let's zoom in on that last case, the one where our point is outside the circle and we can draw two tangents, because this situation leads us to our second big rule for today.
And here it is, Theorem 10.2. This one's another lifesaver in exams. It says that the lengths of tangents drawn from an external point to a circle are equal. What does that mean? It means if you stand outside the circle and draw your two tangents, the distance from your point to where each tangent touches the circle, those two distances are always equal.
Just look at this picture. We've got our point P sitting outside the circle. We've drawn two tangents that touch at points Q and R. This theorem we just learned guarantees that the length of PQ is exactly the same as the length of PR. See those little dash marks on the lines? In geometry, that's code for these two are equal. This is a huge shortcut for solving problems, so lock this image in your brain.
Okay, theory time is over. Let's see how these two big rules actually work in the real world. Well, in the world of exam problems. We're going to put them together to solve a classic question. And don't worry, we'll do it one step at a time. Let's solve this together.
All right, check out this problem. We've got two circles, one inside the other, sharing the same center. That's what concentric means. Now, look at the line AB. For the big circle, it's a chord, right? It connects 2 points on the edge. But for the small circle, that same line is a tangent. It just touches it at point P. Our job? We need to prove that this point P splits the chord AB into two perfectly equal halves. Basically, prove that AP equals BP.
Okay, so how do we start? First, let's just state what we're given. We have our two concentric circles C1 and C2 with center O. We know AB is a chord of C1 and a tangent to C2 at point P. Now, in geometry, when you're stuck, a great first move is often to draw a line. Let's connect the center, O, to that point of contact, P. Let's just draw that radius in.
Okay, now it's time to use our first superpower, Theorem 10.1. Remember that one? The radius and tangent are always perpendicular. So if we look at the smaller circle, C2, AB is the tangent and OP is the radius to the point of contact. So what does that mean? It means OP has to be perpendicular to AB. They make a right angle. This is the key insight. We're using the small circle's property here. Watch this carefully.
And now for the final, really clever step. Let's completely forget about the small circle for a moment. Just focus on the big circle, C1. For C1, AB is just a chord. And we just proved that the line OP is perpendicular to that chord. Now you have to dig back into your memory from class 9. Remember that rule? A perpendicular from the center of a circle to a chord always bisects the chord. It cuts it in half. Since OP is perpendicular to the chord AB, it must cut it into two equal pieces. So AP has to be equal to BP.
And just like that, we've done it. QED. We've proved that AP equals BP. See how we used one rule about tangents and one rule about chords to solve it? It's all about connecting the dots. Awesome job. You've totally got this.
All right, let's do a super quick recap. What are the three big takeaways? 1. A tangent just touches a circle at one single point. 2. The radius at that point makes a perfect 90-degree angle with the tangent. And 3. If you draw two tangents from one point outside the circle, their lengths are equal. That's it. That's the core of this chapter.
Okay, here's a pro tip for your exams. Listen up. Whenever you see the word tangent in a problem, I want an alarm bell to go off in your head. Immediately, start looking for that 90-degree angle. Find the radius, find the tangent, and find that right-angled triangle it creates. I promise you, finding that triangle is often the key to solving the whole thing.
And one last thing before you go. Now that you know all about tangents, I've got a little challenge for you. Start looking for them in the world around you. Seriously. Think about a bicycle wheel rolling on the road, or a basketball just before it goes through the hoop. Where's the point of contact? Keep your eyes peeled, you'll start seeing geometry everywhere.